Okay, let's do our first example. A compact disc rotates up from rest. So your initial angular velocity is 0 and your final is to an angular speed of 31.4 radians per second. So it starts from 0 because it starts from rest, and then it moves. It becomes faster and faster up until the speed is 31.4 radians per second. And this happens after time is 0.892. So time is 0.892. Okay, sama juga macam kita start with a velocity of 0. And then we drive our car faster. And then it reaches 30 km per hour. And how long did it take to reach 30 km per hour? It took you 10 seconds. Which is the same case here. You started from rest to 0 and then it became faster and faster, and then after 0.892 seconds, your speed is now 31.4 radians per second. It's the same case, but it's just rotation. It's now rotation, okay? So what is the angular acceleration of the disk, assuming the angular acceleration is uniform? Now this sentence is very important because our kinematic equation can only be used if our acceleration is uniform. If it is not uniform, let's say you have A1 equals to 10 meter per second squared, A2 is 5 meter per second squared, then you have to divide your problems into two sections. If your acceleration keeps on changing every second, then the kinematic equation is not to be used to solve such problems, okay? So in this case, we can use the kinematic equation. So the equation that I would like to use would be, to solve for A is V equals to U plus AT, because I can't remember the kinematic equation in angular. So I'm going to convert it to omega final equals to omega naught plus alpha t. And this will be 31.4. I start from rest, so it's a 0 plus alpha. Time is 0.892. This will give me alpha as, let's check my calculation. It says here 34.2 radians. The unit is radians per second squared. Okay, and then let's do B. Through what angle does the disk turn while it comes up to speed? So B, okay, so this part is actually for C. So this goes there. Okay, so let's do B. So B is what angle? So it's asking you about angle. And in the linear world, angle is just S, displacement, right? So S, the kinematic equation to solve this would be S equals to UT plus 1 over 2 AT squared. And if I convert it to angular form, this becomes theta omega naught T plus 1 over 2 alpha T squared. Right, and my omega naught is just 0 plus 1 over 2. I already solved for my alpha, which is 34.2. And I know what my time is 0.892 seconds. Squaring that will give me theta of 14. What is the angle for theta? Is it degrees? No, it's not degrees. It's 14 radians. So you write 14 red. Okay? Do not write degrees. It's wrong. You always use radians. Okay, so C. Find the tangential speed of the microbe riding on the rim of the disk. Now remember, we only know what is our omega, which is the speed of the rotation. The speed of the rotation. So this is omega. So now it's asking you what is the V tangential or the linear V. And we can relate V to omega with this equation. V equals to R omega. So I write that down. V final equals to R omega final. That is the equation to use. Because it's asking for final. So if this omega is final, the velocity is also final. And then the radius is given by 4.45 centimeters. Always convert it to SI unit. So this becomes, radius is 4.45 centimeter or 0.0445 0.0445 meter. So that's my radius. V final equals to 0.0445 times with my omega final, which is 31.4. This gives me V final of 1.40 per meter per second. Okay, pretty easy, right? And then D, what is the magnitude of tangential acceleration? Same thing, we can convert our alpha or our angular quantity to linear quantity by a certain equation, and the equation is for alpha or for acceleration is A equals to R alpha. And then A is, we are looking for that, 0.0445. Alpha is 34.2. The answer for acceleration is 1.57. The unit for acceleration, linear acceleration, is meter per second squared. Okay, so that's your first example. Your second example, let's do this. A cooling fan is turned off, which means that it was rotating, blah, 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 and then you say, okay, I'm going to turn this off. Turn off. So what happens? It rotates less and less until it comes to a complete stop. Right? Complete stop. So it was super fast, slower, and then it came to a complete stop. That is what happens when you turn off the fan, right? So at first it was moving at omega naught of 850 RPM, and then it turns theta of 600 revolutions before it comes to a stop. So your omega final is 0. So it's asking, what was the fan's angular acceleration, assuming it is a constant? So let's do this. We have S, we have V. So the equation that we can use is, but first we need to convert these into SI unit. So how do we do that? 850 revolutions per minute time. 1 revolution is equal to 2 pi radian, and 1 minute is equal to 60 seconds. I can eliminate the revolutions and I can eliminate the minutes to give me radians per second, which is my SI unit. And this becomes, let me check. So that is 89.01. 89.01 radians per second. And then this guy, we have to convert it as well. 600 revolutions times 1 revolution is equal to 2 pi. So that is eliminated. So you get, what was it? 3767 radians. 3767 radians. So that is your S or your theta. Okay, so the equation, the kinematic equation that I would like to use to solve this is V squared U squared plus 2 alpha S. We have S, we have, sorry, that's not alpha, that is A. This is not angular. 2AS, right? So if I were to use my angular quantity, that would be omega final squared equals to omega initial squared plus 2 alpha theta, right? Okay. So my omega final is 0. This guy is 89.01 squared plus 2 alpha. We are trying to find alpha. We know what our S is, which is our theta, 3767. So this, solving for this equation gives me alpha as minus 1.05 radians per second squared. So that is your angular acceleration for this problem. How long did it take to come to a complete stop? So now it's asking you for the time. What equation can we use to solve for time? Okay, it's asking you what is the equation to solve for time. So if I were to we try to remember what kinematic equation would be most suitable. V equals to U plus AT, or I can use omega final, omega initial plus alpha T. I have all these quantities, so I can solve for it. Let's do this over here. Okay, so this is B. Okay, so omega F is 0, omega naught is 89.01 plus alpha is minus 1.05 and T. So you can solve for T, which gives me, where is it? It's 84.77. If you get a slight variation from this answer, that's fine. 4.77 seconds. Okay. Okay, next example. Car tires make 65 revolutions as the car reduces its speed uniformly from 95 km per hour to 45 km per hour. So this is linear velocity, right? It's not angular. But this is in angular displacement, right? So we have to convert it somewhere. The tires have a diameter of 0.80 meters. So we usually work with radius, which means that you have to change the diameter to radius. So, okay, so let's write down the information first. So we have a theta of 65 revolutions, right? This is also equal to 65 times 2 pi, I always forget this part, radians over 1 revolution. What am I doing? Wait. It's 65. This is weird. 65 revolutions times 2 pi over 2 pi radians over 1 revolution, right? Cancel out revolution, you get something in radians. Okay, so now it has uniform speed from 95 km per hour, which means that this is your initial velocity per hour to V final of 45 km per hour. The tires have a diameter, so this is your radius. It should be diameter divided by 2. So your diameter is already in meters, you don't have to convert it, but you have to divide it, right? So your radius is 0.4 meters. Okay, what do we do with this information? Let's see what the question asks you. What was the angular acceleration of the tires? You can either convert this to angular or you can solve it in linear form first. For me, I would like to solve it in the linear form. Okay, so this becomes 65 times 2 pi gives me 408.4. What happened? 408.41 radians. And I know how to convert this to linear form. S equals to r theta, where my r is 0.4. My theta is 408.41 radians. And this gives me S of 163.36 meters, right? So that is another information that I have. Do I have to convert this to solve this? Yes, I should convert this to SI units first so that I don't forget to do it eventually. So to convert this to SI unit, you know this already, we did this in chapter 1. Convert kilometers to meters, so kilometer should be down here. 1 kilometer is equal to 1000 meters, and 1 hour is equal to 60 minutes and 60 seconds. So this will give you something. Same thing here. 1 kilometer is equal to 1000 meter times with 1 hour, 60 times 60. Okay, so the answer is, for these two, is 12.5 meter per second. And the other one, sorry, it's terbalik. So 12.5 meters per second. The other one is, no. The initial is larger, so terbalik. Okay. 26.39 meter per second. And the final is, it should be smaller, just 12.5 meter per second. Okay, so what I did was I just converted everything to SI unit, and I converted the angular revolution. I converted revolutions to linear form, which is displacement, using the equation S equals to R theta. That's just it. I converted everything to SI unit. That was the first step. SI unit. And convert everything to a linear quantity. Okay, so that was it. That is just what I did. Okay, so now we can start answering the question. What was the angular acceleration of the tires? In the linear world, angular acceleration is just acceleration, tangential. Okay, so we have V naught, we have V final, we have S. V equals to U squared plus 2AS sounds about right if we want to solve this. So let's do that. How do I move this? Can't move it. Buang dulu. Okay, so V squared equals to U squared equals to U squared plus 2AS. So my V final is 12.5 meter per second. My U is 26.39. Have to square that as well. My 2A and my S is 163.36. Right? So this gives me A of minus 1.65 meter per second squared. It's asking you what is the angular acceleration. So I have the linear acceleration and I can just convert that, where A equals to R alpha. And my radius is 0.4 alpha and A is minus 1.65. So alpha is minus 4.13 radians per second squared. Okay, so what I did was convert everything to SI units, convert everything to linear form, and solve the quantity, and then only I convert it to angular acceleration. If the car continues to decelerate at this rate, how much more time is required for it to stop? So it's asking what is the time for it to stop. So here, let's draw the diagram first. So I started at V naught equals to 26.39, right? This is my initial velocity. And then I reach a certain velocity of 12. So this is my V2. Let's say this is V1. I reached V2 of 12.5 after time is... Do I know the time? I do not know the time. I only know the S, right? Okay, so let's use S. So I only know S. Don't know what time. I only know S, which is berapa tadi? 163.36. And now I'm asking, question is asking, how much more time is required for it to stop? It's asking what is the time for it to stop if the acceleration is the same at this point as well. So it's asking when does V3 become 0 if the A is the same as before. The A before was minus 1.65. So it's the same. The A here was also minus 0.165. But it's asking you what is the time here? How much more time is required for the velocity from 12.5 to become 0. So what is the time? Assuming that the acceleration is the same as before. So I have v here. This should be my u. Now it's my initial and it becomes my final. And I want to find what t is. I have a. So v equals to u plus at sounds about right. Kan? So let's try that. So let's use this side over here. V equals to u plus at. I have v. My v is 0. My u starts from here. 12.5 plus a. The time, I don't know. I know what my a is. Sorry. Control. Oh, what happened? Draw. Eraser. Okay, I know what my a is. It's minus 1.65. And I don't know what my t is. Okay, so solving for t gives me 7.57 seconds. So that is your answer for your part B. Okay. 7.57 seconds to reach velocity of 0 from 12.5. Okay, this is the last example. A pulley of radius 5 cm attached to a motor is used to raise a box. When the motor is started, it accelerates uniformly to an angular speed of 20 revolutions per second in 2 seconds. Okay, so I have a box and I attach it to a pulley, and then I keep on pulling this pulley, and what happens is I get displacement. The box displaces upwards, which gives it from the ground level to a certain height. Okay, so it goes up. So this goes up, so I have a certain height, right? This height is also s. It's displacement in the y-axis. Okay, so what are the information that I have? So I have radius, which is 5 centimeter or 0.05 meters. I start from rest. When the motor is started, maksudnya is dia sebelum tu dia tak bergerak, dia tak ada kelajuan, right? So your initial angular velocity is just 0. Then you reach omega final of 20 revolutions per second. We have to convert this to its SI unit, which is 2 pi radians is 1 revolution, and this will give you 125.66 radians per second. Okay, this is still velocity, angular speed. How do you know it was angular speed? Because of the unit, revolutions per second. If it says revolutions per second squared, then it's acceleration. But now it's revolutions per second, which means that it's velocity or angular speed, angular velocity. Okay, so the time given to reach this certain speed is 2 seconds. So now it's asking how high has the box been raised? Right? So the units that I have is in angular quantity. I can solve this in angular quantity and then convert it to linear quantity. So let's do that. So the equation that would be most suitable to do this is v equals to u plus at, or is it s equals to ut plus 1 over 2 at squared. I have v final, I have initial and final. I don't know what my a is, but I know what my t is. But I want to solve for s. So v squared equals to u squared plus 2as. I don't know what my a is. I don't know what my s is. So either way, I have to still solve for my alpha, right? I have to solve for alpha to get my t. So let's use the easiest one. I like to use this one. So this gives me omega final equals to omega initial plus alpha t. So final is 125.660. Alpha is unknown. Second is 2. Alpha gives me 62.83. The unit is radians per second squared. Okay, second squared, not radians per second, but radians per second squared. So now I want to find what my S is. So I can use this equation now because I already have my A. So let's do that. So V squared is omega final squared equals to omega initial squared plus 2 alpha theta. This guy is 125.66 squared equals to 0. 2. My alpha is here 62.83 and I am solving for theta, which gives me 125.66 as well, but in radians. So now it's asking you what is the height, right? The question is asking you calculate how high has the box been raised. So if I know what my angular displacement is, if I know what my theta is, I can know what my S is. And my S is my H. So this is my S. Sorry, this is my theta. Okay, so I need to convert that. So S equals to R theta. My R is, what is the radius? It's 0.05 times with theta 125.66. So 0.05. So that gives me a height of 6.283 meters. So the height that the box was lifted is 6.28 meters. That's your final answer. That is H. Okay, so that is it. And I will explain to you why when we multiply radians with a unit meters, the answer is still in meters in class. Okay? Okay, so the issue here is this guy is in meters, this guy is in meters, but this guy is radians. Where does the radians go? So we will answer that in class, in live class. Okay? See ya.